Okay, so we have discussed about frustum, we have discussed its volume and its curved surface area. Now let us revise that concept. The frustum that we have considered was something like this. This kind of frustum we have considered, and this represents the height of frustum, which is h, okay, and this is the radius r2, radius of base 2. We have considered this as base 2, this as base 1, okay, and the radius r1 is for base 1. Okay, this is what we have discussed about frustum. Now we have also discussed that this frustum is a part of a cone which is formed by cutting the cone into two parts such that the plane that cuts the cone is parallel to the base, and that's why the two surfaces, the two faces of this frustum are parallel to each other. And we have derived the formula for volume of frustum. So the volume, or let us write it here, volume of frustum. Now what is meant by volume? Volume means the amount of water it can contain. Okay, in simple terms you can understand the concept of volume, that it is the amount of water that this particular solid figure can contain. So volume of the frustum we have discussed. The formula for volume is 1/3 pi h to the bracket r1 square plus r1 r2 plus r2 square. So this is the formula for volume that we have discussed, where r1 is the base radius, r2 is again the base radius of another base, and h represents the height, okay, and 1/3 and pi are constant. Now this formula may be a bit difficult to remember. Okay, you might feel that this formula is difficult to remember. So what we will going to do is, let us modify this particular formula so as to remember it better. What we will going to do is, we will simply multiply this pi inside the bracket. Okay, we will multiply this pi inside the bracket, and what we will have is 1/3 h to the bracket pi r1 square, okay, plus pi r1 r2 plus pi r2 square. So this is what we are going to have. What I did is just multiply this pi inside the bracket, so you will have this value. Now in this value, if I observe this value very carefully, what I can see is this pi r1 square. Now what is pi r1 square? Pi r square represents the area of a circle, and r1 is the radius of the base of this frustum, which is a circle. So since this is a circle and r1 is the radius, I can say the area of this base 1, I can say area of base 1 is what? Area of base 1 is what? It is pi r1 square. Okay, it is pi r1 square, and let us represent this area of base 1 by a1. Okay, so a1 represents the area of base 1. Similarly, if I observe this pi r2 square, again I can see r2 is the radius of this base. So what I can say is area of base 2 is pi r2 square. Now area of base 2 is pi r2 square, and let us represent it by a2. So a2 represents area of base 2. So in place of pi r2 square I can write a2, in place of pi r1 square I can write a1. Okay, so what I can write it as, it is 1/3 h as it is to the bracket. Now pi r1 square, pi r1 square is basically a1, so in place of pi r1 square I will write a1, plus, now what about this pi r1 r2? Just think about this pi. This pi is basically a complete number, okay, this is pi. Can I write this pi as root of pi into root of pi? Okay, this pi can be written as square root of pi into square root of pi. So square root of pi into square root of pi will give you pi only. So what I can see is this particular value pi r1 r2, this value I can write this as root of pi into r1 into root of pi into r2. Can I write it like this? Okay, root of pi into r1 into root of pi into r2. Now further, this is r1. Now can I write r1 as square root of r1 square? I can see these two values are similar. r1 as square root of r1 square and r2 as square root of r2 square. So what I can see is, in place of pi r1 r2, which is root of pi into r1 root of pi into r2, I can write this value as square root of pi into square root of r1 square to the bracket square root of pi into square root of r2 square. So this will give you square root of pi r1 square into square root of pi r2 square. Okay, now what is square root of pi r1? Okay, square root of pi r1 square. Pi r1 square is a1, pi r2 square is a2. So what I can see is, in place of this value pi r1 r2, I can write this value which is equal to a1 into a2. So in place of this I will write a1 a2 plus this is pi r2 square which is a2. So the new formula or the modified formula for the volume of a frustum becomes 1 upon 3h a1 plus a1 a2 plus a2. Okay, sorry, this is not a1 a2, this is square root of a1 a2, this is square root of a1 a2. Okay, the square root, this pi r1 square is a1, so it is in the square root, so you will get root of a1 and this is root of a2. So finally a1 plus square root of a1 a2 plus a2 will be the volume of this frustum. Okay. Now the next thing that we have discussed was curved surface area. The curved surface area of frustum was pi into L to the bracket r1 plus r2. This is what we have discussed, where L represents the slant height of this frustum. So let us mark the slant height. This is L, which represents the slant height of frustum. Okay. Now this is just the curved surface area, but one more thing that I need to determine is the total surface area. Now total surface area will have different formula depending on the frustum. What I mean to say is, if this frustum is made from a hollow cone, then the total surface area will be different. If this frustum is made of a solid cone, okay, then the total surface area will be different. So let us write the different total surface areas that we will have depending on the nature of the right circular cone that we have taken. So first we will define total surface area of frustum formed from a hollow cone. Okay, first we will define the total surface area formed from a hollow cone. That is, if I have a right circular cone which is hollow, okay, which is made up of paper, in the inside of this cone there is air, nothing else. Okay, so in that cone, if I cut that cone and made a frustum, what you will see is, in this kind of cone I will have a frustum like this, And in this frustum, since it is made of a hollow cone, we will have this base as closed. Okay, this base as closed because the hollow cone also have a base, but the top base, this one, base 2, this base 2 will be open. Okay, this base 2 will be open. So there is nothing here, nothing here. There is a base in this frustum, but this is open because it is a hollow cone. So if I cut a hollow cone, since there is nothing inside the hollow cone, so this base will remain open to air. Okay, there is nothing available here. There is no covering. Okay, this is not covered. So in this case, if I write the total surface area, now what is the total surface area? Total surface area is equals to curved surface area plus area of bases. Since we have two bases here, so which base should I consider? The radius of this base is R1 that we have previously defined, and the radius of this base is R2 that is also we have previously defined. But since this base 2, this R2 base is open, so I will not consider this for total surface area. So the total surface area will become, and this is the slant height, let us mark the slant height as L. Okay, so the curved surface area is same as that we have previously derived, pi L into R1 plus R2. This curved surface area will remain same whether it's a hollow cone or whether it's a solid cone. Then plus, now area of bases. Which base should I include in this case if I want to have a hollow cone? If this frustum is made of a hollow cone, then definitely I told you that this base is closed but this base is open, so only this base will be considered in the total surface area. Try to understand this, that total surface area matlab, total surface area means it is the area on which you can paint. Okay, हम उस फ्रस्टम के उस एरिया की बात कर रहे हैं जिसपे आप पेंट कर सकते हैं, जिसपे आप कलर कर सकते हैं. सिंस जब आपने इस फ्रस्टम को कट किया एक हॉलो कोन से, तो हमने देखा कि यहाँ पर जो बेस क्रिएट हो रहा है ये बेस कवर्ड नहीं है, तो क्या इस बेस पे मैं कलर कर सकता हूँ? नहीं. हम इस पे कलर कहाँ कर सकते हैं? सिर्फ और सिर्फ इसके बाउंड्री पे प्लस इसके बेस पे. ओके, दिस बेस जो बड़ा वाला बेस है सिर्फ यहाँ पर. दैट्स व्हाई आई विल से इन दिस केस टोटल सरफेस एरिया में सिर्फ और सिर्फ ये वाला बेस काउंट होगा, दिस बेस विल नॉट बी काउंटेड. So area of this base is what? It is pi r1 square. So this is pi r1 square. So if a frustum is made from a hollow cone, then the total surface area will be pi l r1 plus r2 plus r1 plus pi r1 square. This will be the total surface area, that is the area of this larger base. Okay, so you need to be very careful. Now if I have a solid cone, total surface area of a frustum made from a solid cone. Okay, if I have a, let us say, a metallic cone which is completely filled, inside that cone there is also metal. So for example, if you consider a rod, a metallic rod, so there are hollow rods also, okay, and there are filled rods, that is solid rods also available. So in similar manner, if I have a cone which is completely filled, okay, for example a wooden cone, inside a wooden cone you will find wood, okay, so I will say that wooden cone is a solid cone. So if I cut that wooden cone, if I cut that solid cone, what will happen? I will get a frustum whose shape will be similar to a hollow cone, but the extra thing that this particular frustum will have is that this base will also be closed, okay, and this base is already closed. Try to imagine a wooden cone. You made this frustum from a wooden cone, you have a wooden cone, you cut it from the from this height, and you will get this kind of frustum in the manner that this is closed and this is closed, since it's a solid cone. So here also the other parameters will remain same, that is the slant height L and the height H, but the only difference between this and this cone is that its upper base is open but its upper base is closed. So it means if I want to color this frustum, I can color the curved surface area, I can color the base, as well as I can color the top of this frustum. So in this case, total surface area will be equal to curved surface area plus area of base 1 plus area of base 2 also. We will include the area of base 2, and this is base 1 as per our convention, and this is base 2 again as per our convention. So here I will write that the total surface area will be curved surface area, that is pi L into R1 plus R2 plus area of base 1 is pi R1 square plus area of base 2 is pi R2 square. So this will represent the total surface area of this cone, which is made from this frustum, which is made from a solid cone. Okay. So this is how we will going to define the total surface area. Now consider if I have a bucket. What happened in case of a bucket? In case of a bucket, the bucket has a shape like this. Okay, this is the shape of a bucket. I can see this bucket is similar to this kind of hollow frustum, but it is just reversed. So what is the base in this case? I will say this is the base. So in case of bucket, this larger base will be open, okay, and this lower base, the smaller base will be closed or covered, okay, and other things will remain same. So we will solve a question on the bucket, then we will understand what exactly the concept is. There is nothing extra, only the thing is that this hollow cone is reversed and we covered this base and opened this base like this. Okay, you can see a bucket, this is closed, this is open. So definitely in case of total surface area, I will consider only this base, not this base. Okay, and the curved surface area will remain same. Okay, so this is how we have defined the total surface area. Now depending on the question, we will discuss some questions of which may have a special case. So you need to be very careful while solving the question. So first you note this, then we will start solving the questions. Okay, let us now solve some questions based on concept of frustum. We will start solving from question number 38 from the practice sheet. Let us discuss this question. The question says the radii of the ends of a frustum of a cone 45 centimeter high are 28 and 7. Okay, find its volume, the curved surface area and the total surface area. Okay, so what we can see is, it says that there is a frustum which is made from a cone and we need to determine its total surface area, its volume as well as curved surface area, and the diagram shows the details of this particular cone. Okay, so let us solve question number 38. For that, let us first draw the diagram given in the sheet. The diagram is this is a frustum. Okay, the height of this frustum is given as 45 centimeters. Further, its radius, its radii are given as, this is the first radii which is r equals to, let us say this is r1, or let us say this is r2 which is 28 centimeters, and this is the radii which is, let us say r1, it is equal to 7 centimeters. So this is the detail that is given in this question. Now it says find its volume. So the first thing that we need to determine for this frustum is its volume. So what is the formula for volume? Volume of frustum is equals to 1 upon 3 pi h to the bracket r1 square plus r1 r2 plus r2 square. Okay. So you can use any of the formula. You can either use this formula also, 1 upon 3 pi 1 upon 3 h to the bracket a1 plus square root of a1 a2 plus a2. Okay. Now it depends on you which formula you want to use. You can use either this one or this one. So let us use this formula. Let me use this formula. So I am rubbing this formula. It's totally up to you because answer will remain same even if you use the second formula. So here I can write it is 1 upon 3 pi. Now h. H means the height of frustum, which is 45. So it is 45 to the bracket. Now r1 square, r1 is this 7. So 7 square is equal, 7 square plus r1 is 7 and r2 is 28 plus r2 square is 28 square. Okay, so this 5 and this is 15. So you will get 15 pi to the bracket, this is 49 plus 7 into 28 is 1 into 2, 7 into 2 is 14, so 140 and 7 8s are 56. So 140 plus 56 will give you 196. Now plus then square of 28. How will you calculate the square of 28? See, the square of 28 will be equals to 2 square, that is 4, oblique 2 into 8 is 16 into 2. 16 2s are 32, then oblique 8 into 8 is 64. So square of 28 will give you, then 4, this 6 will go here, 32 plus 6 will give you 38 and 8 will be here and 1, this 3 will go to this 4 and 7, this 3 and 4 will give you 7. So square of 28 will be 784. Okay, so here I will write 784. Remember, I have discussed this concept in one of my lecture, that how to calculate the square of a number in quick method. Okay, so this will give you 784. So 15 pi into this value, this addition and plus 784. Okay, this much centimeter cube will be the volume of this frustum that we have considered. Okay, you can see this is the volume of the frustum that we have considered. This is the height, this is the radius 1, this is the radius 1, this is the radius 2, and just apply the formula, substitute the values and you will get the final answer. Now it's up to you how to calculate this. Okay, so we have solved the question number 38 and you can see this question is very easy. Okay, sorry, we haven't solved this completely. Let me solve it completely. We need to define the curved surface area, we need to determine the curved surface area and total surface area as well. So curved surface area, if I talk about the curved surface area of frustum, then what is the curved surface area? It is pi L R1 plus R2. Okay, now to calculate this L, what is the L? What is the value of this L? L is the slant height. Let us mark this slant height here. This represents L. Okay, so L, the slant height, the formula for slant height is equal to square root of h square plus r1 minus r2 whole square. Okay, so from here I will calculate the value of L. Here I can substitute the value of h, which is 45, so square of 45 plus r1 minus r2, r1 is 7 and r2 is 28, so square of this value. Okay, now remember, you can write it as r2 minus r1 or r1 minus r2, it do not matter. Why? Because it's a square, so in either way it will be positive. Okay, there is no hurdle to have a negative value here. We can always have a positive value because this r1 minus r2, this difference is always squared after difference. Okay, that's why I can write it here. So this will give you square root of 45. Now what is the square of 45? 4 into 5 is 20 and square of 5 is 25. So 4 into 5 is 20 and square of 5 is 25. So square of 45 is 2025. Okay. Plus, remember I have discussed this trick also, how to calculate the square of 45. Okay. How to calculate the square of those numbers which have 5 at their end. So now 7 minus 28 will give you 21 square, and what is the square of 21? Square of 21 is 441. Okay. So you will get square root of 2. Now let us add this. This will give you 4, 6 and this is 6 in centimeters. So the slant height is 2466 centimeters. Okay. Now we have the slant height. Let us calculate the curved surface area. The curved surface area will be CSA will be pi into L, that is square root of 2466 into R1 plus R2. R1 is 7 and R2 is 28. So this will give you pi into square root of 2466. Now how to calculate the square root of 2466? For this we have discussed the long division method. Try to remember the long division method that I have discussed in polynomials. Okay. Now plus 28 plus 7. So this will give you 30 and 5 is 35. And this is in centimeters square. So this is the curved surface area. Now the last thing that we need to determine is total surface area. In the total surface area, since it is not given that which kind of cone I have used, is that a solid cone or is that a hollow cone, it is not given. So if it is not given, then by default what should I consider? I will consider that this is definitely a solid cone. It means in the total surface area, I will write the total surface area as curved surface area plus area of base 1 plus area of base 2. Okay, I will add both the areas. So curved surface area is, this is what we have, that is CSA plus area of base 1. Area of base 1 is pi into 7 square plus area of base 2 is pi into 28 square, and this much centimeter square. This is the total surface area of this frustum. Okay. So this is the volume, this is the curved surface area, this is the curved surface area, and this is the total surface area. So in this manner you need to determine the values. The only confusion that may arise is that why I have used the area of both the bases. It's just because since the kind of cone, the nature of cone from which this frustum is taken out is not given, so I will consider that definitely the cone from this cone which is used to make this frustum is a solid cone. Okay, that's why I have added both the base areas, and this is how you need to determine this total surface area. Okay, so in this way, question number 38, we need to solve this question. Okay, so it's a basic question, it's just a matter of application of the formula that we have studied for curved surface area, total surface area and volume. But you need to complete this question, you need to calculate these values. Now let us discuss the question number 39. Question number 39 says, A and his wife B are busy making jaggery out of sugarcane juice. They have processed the sugarcane juice to make the molasses, which is poured into molds in the shape of a frustum of a cone, having the diameters of its two circular faces as 30 centimeters and 35 centimeters, and the vertical height of the mold is 14 centimeters. If each centimeter cube of molasses has mass about 1.2 grams, find the mass of molasses that can be poured into each mold. Okay, so what it says is that there are two persons, A and B. What they did is they processed the sugar cane. Okay, they processed the sugar cane and the molasses. You have studied this process in your chemistry subject, that how the sugar cane is processed and the molasses is produced, how to make the sugar. You might have studied this concept, you might have studied this process in chemistry in carbon compounds. Okay, so sugar is made from the sugar cane, and how that sugar cane is processed. So there are some processes in between, and one of the process is written in this question. It says that they processed the sugar cane and we got molasses. Molasses is what? It's a liquid. Molasses is a thick paste form liquid which is formed, which is like a byproduct in case of we are making sugar from the sugar cane. So it's a byproduct. So what they did is they poured this molasses into frustum shaped buckets. Okay, what they did is they poured this molasses, this thick paste liquid, in the frustum. Okay, in the shape of a bucket, which is in the shape of frustum. So this frustum has a height of 14 centimeters. Each frustum has a height of 14 centimeters, and the radii of its bases are 30 centimeter and 35 centimeter, as you can see in this figure. So what the question is asking? Question says that what I am doing is I am pouring the molasses into a single frustum. I have multiple frustums. Okay, I have multiple buckets, that is containers. I am filling that molasses in those containers, and I need to determine how much weight of that molasses can be poured in each container. Remember, it is given that each centimeter cube of molasses. Okay, now since I told you that this is a liquid, so what I can consider is I can consider the unit for this molasses, the unit for volume of this molasses as milliliters also, because we know one concept that 1 ml is equivalent to 1 centimeter cube. We know this concept. So it says if each centimeter of molasses has a mass of 1.2 grams, then find the mass of molasses that can be poured into each mold. So how the mold looks like, let us draw the diagram. So question number 39, the diagram for the mold is like this. This is the diagram for the mold, and the two circular faces, the diameters of two circular faces, this diameter is 30 centimeters and this diameter is 35 centimeters. This is 35 centimeters, and the height of this frustum is 14 centimeters. Now I need to determine the mass of molasses that can be filled into a single frustum. So if I start filling this bucket, if I start filling this frustum with molasses, what will happen? This molasses will start occupying the space inside this frustum. And how much space this molasses can occupy inside this frustum? When I will say that enough amount of molasses is filled inside this frustum, it will be only when the volume of this molasses becomes equal to the volume of this frustum. Okay. So what I mean to say is, what is the maximum amount, what is the maximum volume of molasses that I can fill inside this frustum? It will simply be equal to the volume of frustum, because if I try to fill molasses more than the volume of frustum, then what will happen? The molasses will overflow. So maximum volume of molasses that can be filled in the frustum is equals to, or let us write not in the frustum, let us write it as container or the bucket. Okay, the word used in the question is into the molds, okay, or the mold. So the maximum volume of molasses that can be filled in the mold is simply equals to volume of mold, or I can write it as volume of frustum. Okay, so this much is the maximum volume of molasses that can be filled inside this cone, inside this frustum. So the maximum volume of molasses means I need to simply determine the volume of frustum. So the volume of frustum is, what is meant by the volume of frustum? It is 1 upon 3 pi h to the bracket r1 square plus r1 r2 plus r2 square. So this will give you 1 upon 3 pi h is 14 to the bracket r1 square. Now what is radius 1? Let us say this is base 1, so this is r1, the radius of this base is, let us say, r1, and the radius of this base is, let us say, r2. So the value of r1 is, this is r1, the value of r1 is half of this 30, that is 15 centimeters, and the value of this r2 is half of this 35, so I will write it as 35 by 2 centimeters, okay, instead of 17.5 centimeters. So this is radius 2, this is radius 1. So we will substitute these values. R1 is 15 square plus R1 into R2. So 15 into 35 by 2 plus R2 square. R2 square, this is 35 by 2 whole square. This is R2 square. So this means the volume of frustum. Now let us name this volume of frustum as V1. Okay, so V1 centimeter cube is the volume of frustum. Now it says calculate the mass of molasses that can be poured. So this is the mass of molasses as well as the mass of frustum. So mass of molasses, if I want to determine, what is given in the question? The data given is each centimeter cube of molasses. That is 1 centimeter cube of molasses will have a mass of 1.2 grams. So it means if I have a small cube of molasses which is 1 centimeter cross 1 centimeter cross 1 centimeter, then its mass will be 1.2 grams. So 1 centimeter cube has a mass of 1.2 grams. So definitely V1 centimeter cube of molasses will going to have 1 upon 3 into pi into 14 to the bracket 15 square plus 15 into 35 by 2 plus 35 by 2 whole square, okay, into 1.2, and this much mass in grams. So this is the mass of molasses that each mold can hold. Okay, this is the mass of molasses that each mold can hold. Now it's just a calculation, you need to calculate it yourself. I have told you the concept. And anything else in this question? No. So this is the question number 39. Only this much is the solution that we need to have. So we have completed the question number 39. Okay, so first you note this, then we will continue.